recorder here and share my screen. Um, I will share my screen. Can you guys see my screen? So we've been discussing conductor considerations and conduit. Yesterday I went over what the training video that I sent earlier, what it was all about, and the importance of these topics has to relate to following the right procedures and taking into consideration the right conductor and the right wiring when doing PV installations, and what happens if the right thing is not done, the detriments or the harm it could bring to the lives of people. We spoke about that yesterday. Just for a quick overview of what we talk about, let me just run through this quickly. We spoke about what current is and what amplicity is, the difference between current and amplicity. We described the characteristics of conduct materials and the installations. We differentiated between the difference. We differentiated between the difference conduct size, and we determined that now we're going to be determining the color coding of conductors based on wire type and socket characteristics. So that's what I'm going to be diving in today. In furtherance of what we discussed yesterday, I'm going to be talking about determining color coding of conductors based on wire types and socket characteristics. As you do notice, I try to articulate more fluently because apparently other people who are non-Liberians are interested in taking advantage of some of the training video that I am preparing. So it's becoming a little bit diverse. So if you don't understand my dictions, you should let me know. And to say for the fact I'm a crew man, as you do know, crew people like big book. But if you can't understand anything I say, being English is not our first language, you say to me, Mr. Man, you're speaking big book. I don't understand it, and then I will re-enter it. I'll go back to talk about it. Okay? All right, guys? All right. So let me dive right in. Now, they say current and amplicity. Just to preview it, the amount of electric charge flowing through a conductor measured in amperage, the amps. The amplicity is the maximum amount of current a conductor can carry. A conductor can carry before sustaining damage. The higher the amplicity, the more current a conductor can safely carry. Now I'm gonna symbolize this here in the more physical way. If I was to take a bag of rice and put it on your shoulder and ask you to walk down with a bag of rice, there is a maximum of distance you can go with that bag of rice on your shoulder that you will still be comfortable going with it. If you pass that distance, it becomes more heavier on you. You got it?
Yes.
Now, if I was to take a half a bag of rice and put it on your shoulder, you may go twice the distance you went to. You may go more of a distance as compared to the one bag of rice or the full bag of rice on your shoulder. So that's what they are saying is that the current is the amount of the electron that are flowing through the conductor. But then the amplicity is the maximum. It can exceed. This is the max. This is how far it can stop. It's like when you are towing something heavy, you have a max that you have to say, oh, I'm tired, I gotta rest. That's just your max. So that's what they're saying here. Now, the higher the amplicity, the more current a conductor can safely carry. That explains itself. The higher the amp, the more current the conductor can carry. The lesser the amp, the lesser current the conductor can carry. Is that clear?
Yeah.
Okay. We talk about wire default in terms of the conductor and the insulation's material, the conductor material. We spoke about copper and aluminum. They said the better conductor, coppers or aluminum, less expensive. Aluminum is less expensive than copper. Copper wire is standard in more residential and PD applications. Aluminum frequently used on larger scales. Why do we use aluminum on larger scales? Because it's what? Less expensive, not so? Number one is less expensive. Now, solid limit in size or standard many smaller wire usage. So there's another one called solid. But wire type differ in the conductor material and insulation. The conductor carries the current, and the insulation keep the electric inside the wire. So the insulation does not contain current. The insulation is just to keep the current inside the wire. That's what we talk about. Just a preview. Now I'm going to go to what I'm going to discuss today. And that will be on page number 11. If you have your reading material or if you're looking at it from your, we're moving to page number 11. All right. Conductor consideration, international wire size compared to AMG. The conductor area, the millimeter 2, the standard metric size, the standard AMG size, the conductor area, the standard metric size, the standard AMG size. So they are saying a 2.08 millimeter conductor, the standard size, it don't have a standard size. A 2.5 has a standard of 2.5. A 3.31 has no standard. So if you do electrical wiring and if you've been doing some AC wiring, like is Jala in there?
Jala is not here.
Okay, Jala is not there. But is there anyone in there who have done some wiring in terms of AC wiring?
Yes.
Okay, so you have done AC wiring. You do use AWG wire, don't you?
We use AWG. If it's 10 or 12 or 14.
So what gauge, what size do you use?
We use 10, we use 12, and we use 14.
So you use 10, you use 12, and you use 14. Okay, so these are the wire size that you use typically for how you call it, for AC wiring if you are a technician, electricians. So that that also is being used. But in DC wiring, we also use the AWG, which is the American wire gauge. We definitely use the AWG, but just that we use different size. So size in terms of wiring is important. What wire to use at what kind of job depends on the job you're going to be doing, depend on the runs, how long, depend on the climate and the climatical condition, whether it's in a hot environment or a cool environment or on the ground, whether it's in the attics, what is on top of the roof. All of those things have to be taken into consideration when choosing the right wiring for your job. Let me read a little bit. They say, in this lesson, we will be using American wire gauge, which is a standard in the United States, but other countries use standard metric size, which are based on the conductor area in square millimeter, MM2. And to the second power. Understanding metric size is quite easy. The smaller the conductor area, the lower its amplicity. And likewise, the larger the area, the higher the amplicity. The trace size in metric directly relates to the conductor's cross-sectional area. For example, a standard metric size conductor called 10 millimeter has a conductor area of 10 millimeters simply. So you see what it's saying in the metric area, over here. So these are metrics. We have a metric here. We have 2.5, 4, 6. Those are metrics, which are the standard metrics. These are metrics. These are metrics. These are standard AWG size. The conductor area, the standard metric size, and the standard AWG size. So it's very important. Why is it important to understand the metric gauge? Because you may not have access. Maybe you went to get your wiring and they don't have AWG wiring and they don't have AWG wires. They only have metrics wire, standard metrics size. And you say, oh no, I can't use that wire because I don't understand it. What you're saying here is you can use this chart to determine. You understanding me?
Yeah.
So a 2.08 in the metric will be 14. At 3.31, there's no metric for that. In AWG size 12, which is you use. Now here we have a 5.26. They don't have metric sizing for that, but here is a metric size right here. 6. We have a 6 here. We have 8.3. They have an AWG size. So if you look at the chart right here, you can determine what wire is about the same size. And they're saying here is what they're saying, understand the metric size is quite easier. The smaller the conductor area, the lower the amplicity. So the smaller conductor area, I sure they may have an illustration as we go further to show us what that means. This chart shows standard metric and AWG conductor sizes as well as the actual conductor area in square meters, millimeters. AWG size and metric size don't exactly match. So when converting wire to a different size, it always safest to go up to the next largest wire size. You hear what I said?
Yes.
It said the chart up there, the start shows standard metric and AWG conductor size. Those are the standard. As well as the actual conductor area in square millimeters. AWG size and metric size don't exactly match. Now, over here, it's saying right here, we have a standard metric right here, and they are calculated in millimeters. If you have a 2.5 matrix, that is the conductor area, which is 2.5. You don't have a replement of that in the AWG. You seen it?
Yeah.
So if I'm using a 2.5 metric size wire, I have to go up. You hear what I said?
Yeah.
You got to go up. Right here. It says right, let's go over it again. I want us to go over this because this is important. I'm going to read this again. It says, I'm going to read, understanding metric size is quite easy. The smaller the conductor area, the lower its amplicity. And likewise, the larger the area, the higher the amplicity. The trace size metric directly related to the conductor cross-sectional area. For example, a standard metric size conductor called a 10 millimeter has a conductor area of 10. Now, you see when it comes to AWG, the conductor area is different from the standard size. You got it?
Yeah.
This is a conductor area 2.08. The standard size is 14. But for metrics, the conductor size is 2.5. The standard size is what? 2.5. It's not different. We have right here the conductor area is what? 6. The metric size is what?
6.
Now for AWG, the conductor size is 8.38. The standard size is what?
8.
So there is difference in the area size and the standard AWG size for AWG wiring or conductor. But for metrics, it's simple. They don't change. They remain the same. If you have a 10 area conductor, in the metric is 10. If you have a 16 area conductor, in the metric is 16. You got it? You get it? You guys getting the idea?
Yeah, we got it. Good idea.
If you have, so if you have a 2.8 2.08 millimeter area. In the AWG, that is 14. So there's a little bit different there. Not so?
Yeah.
It's a little bit different. Now, the rest of the world use metric system. America use the different system when it comes to measurement. The standard, the different system, inches but other area they use metrics. So if you want to do your job right, you also want to familiarize yourself with metrics measurement. You want to familiarize yourself with that, so that when you get a job, you never know. Maybe you get a job where the materials that you're going to buy, they're going to be in metrics. So you got to be able to know what it means. Hello?
Yeah.
Okay. Let's proceed. It will make sense as we go forward. Will sink into your brain as we go forward. Let's say right here, conductor consideration. It said construction and applications. Single conductor. The type. You remember the THWN2? Who remember that? THWN2. The conductor. Who can tell me what that stands for? THWN2.
THWM2.
The THWN2. Who can tell me what that stands for? All right, let's go back to the type of wire. Come on, I'm going to go up here because I understand that your material when I printed, so apparently some people don't have, but I sent it to your email as well. But apparently, some people want everything to be done in, I don't know, the Liberia way. Right here, THWN2. You remember this? The thermoplastic, high heat, water resistant, nylon coated. That is the wire. We talk over here when we talk about types of wires. We talk about THWN2. We spoke about the USE2, the RHW2, the PV wire, and remember THN2, the types of wire. Other types of wire, these are the different types of wiring. When it comes to PV installation, these are the different types of wiring. That's what we spoke about. So THWN2 is a type of wire. And it's a wire that is suitable, it's a suitable choice for PV system. When wire is to be run in conduit, the two at the end refer to a 90 degrees Celsius temperature ratings. This type of wire is suitable for use in high heat, wet or dry condition. We spoke about that yesterday.
Yeah, we spoke about it.
Hello?
Yes.
Okay, so you guys have to read your material.
Yeah.
You got to familiarize yourself. You cannot learn or read it. You have to read your material. Because I sent it to your emails.
Yeah, I have
to access your emails.
I have the purpose for it, but I don't get the definition.
Okay, so that's what it is. You have to know familiarize yourself with some of the different types of wires.
Yeah.
So if you were to go to buy wires and you see an RHW2, you know the type of wire, you know what that wire is for.
Yeah.
It's a rubber insulation, high heat, water resistant. This insulation is some type of rubber or XLP, cross-linked polyester, suitable for high heat. What that word stands for? I can pronounce that word. Poly. Polyent. Okay.
Oh, yes, yeah. Yes, yeah.
Polyester. LENE. Okay, the link polyethylene, suitable for high heat and is moisture and sunlight resistant. So depending on the environment in which you are going to be using your wiring for, whether it's outdoor, whether it's indoor wiring, whether it's on the roof, you should know what wire will work well. Except you're going to buy a PV wire. They have a wire called PV wire. So PV wire is a new type of wire specifically manufactured for use in PV systems. It is sunlight resistant, suitable for wet location, rate for high heat, and is available with voltage ratings of 1000 volt or higher. PV wire is more expensive than many other wire types, but it usually meets all the requirements by PV system installation, especially on the DC side of the PV system. So if you don't be bothered about choosing which wire, you can just put PV wire or you can estimate for PV wire. But bear in mind, it's going to be more expensive as compared to a THWN2 wire or a THS. You're going to be more expensive, but it's going to save you time to determine what wire to use where. If you have a PV wire, it's definitely made for PV installations. So all of your DC installations will be all set. But they say right there, it's expensive. Hello? So please familiarize yourself because we are going to be doing some exercise on some of these materials. We're going to do exercise on some of these materials. I'm going to send you guys quiz that you have to take as well. So please don't just come to the class and go home and just forget about the material. Find time to adjust to digest the material, okay? That's the reason why when you eat, they say sit down. Why do we sit down when we eat or rest? Because our food has to digest. It's the same way we're learning. You have to find time to make the material resonate so it can sit there in your brain. Okay, guys? All right, now you're not going to be master these things overnight. I'm not expecting that. I'm just expecting that you should read a little bit to be familiar, okay? All right, gentlemen?
Yeah.
All right, now let's go over here. The THW2, the area of use, single conductor for use in conduit. The max temperature is 90 degrees all the way to 194 Fahrenheit. The application provision, dry or wet. The insulation covering, flame retardant, moisture and heat resistant thermoplastic nylon jacket. So they're saying right here the construction and application symbol, they're telling you how this is constructed. For this wire here, THWN2, you have a single conductor for use in conduit. The maximum temperature can function on a 90 degree all the way to 194 degrees Fahrenheit. They will work well in dry and wet environment. So if you're doing wiring in Liberia and they give you THWN2, will that wire work for that area?
Yes.
Because you have dry and wet season. You don't have snow, you don't have cold season, you have dry and wet season. So that's a good wiring for such a geographic location. That's what they're saying. Then we have the PV wire or the USE2/RHW2. Now these are single conductor cable for exposed area wiring. Exposed area wiring. 90 degrees all the way to 194 degrees Celsius, dry and wet. Heat moisture resistant, sunlight resistant. The USE2 must be dual listed. The RHW2 if used indoor. So they're saying here, they're saying why the PV wire or if using it in indoor, it should be dual listed. We'll talk about that later. It has what? Moisture resistant. The wire has moisture resistant. Now, they're showing you here. This is my PV array. PV wire or USE/HW2 wire. This is my PV array. You see the wire going up here?
Yeah.
The wire from your PV array, you have an array of 3 solar panel over here, 3 PV model here. It's going over here over to what? Your junction transition box. Okay? Going into your junction transition box, you have a conduit and you have your TAW2 wire inside your conduit. Remember we spoke about that?
Yeah.
So we have your TAW2 wire inside your conduit. Now this junction box here, it should be, assume it's inside, you need a conduit. Why do we need a conduit?
We need a conduit to protect the wire or to stop shot and injuring people.
For protection and safety reasons so that you can't shock anybody. Also,
Yes.
what happens if we just could do our connection and run the wire here and put click on it and put pin on it or put tape on it? What's going to happen?
The wire will burn or there will be a shock in the future.
There will be a shock in the future. So that's what you're saying.
That wire.
Yeah. Excellent. Hold on 1 second, guys. Hello. I hello? All right, sorry, I had a business call. Now, so we move forward here. Wire type must be appropriate for the particular location and method of installation. Acceptable conditions of use are defined in the National Electrical Code. This table is exempted from the NEC table 310.401A and show information on 2 common types of wire used in PV system. The THWN2 is single conductor wire that range in size from 14 AWG up to 1000 kc miles. It can be used in dry or wet location, but because it has a nylon outer jacket, it is not UV resistant and must be in conduit or some other type of raceway. What they are saying here, they are saying is this wire it does not work well in the UV, the UV light from the sun.
Yeah.
So they are saying the UV light from the sun exposure to this wire may not it will affect the wire. So you must put it into a conduit. You need a conduit if you're using the THW2 wire, the single conduit conductor that range inside from the 4 AWG or to 1000 kcm. It can be used in dry or wet location. Yes, it can. But because it has a nylon outer jacket, it is not UV resistant and must be in conduit. What means that if the sun keeps shining on the wire itself, it may what? It may destroy the outer coating of the wire. So that's why you have to put it in the conduit. Okay? Hello?
Yeah.
It seems you guys are lost. You guys doesn't seem to be part of you guys are you guys not, is the audio not clear enough?
The audio clear.
Okay. Hold on, let me see.
We get you. The audio is clear.
Yeah, but I like for the class to be participatory. If you're not understanding the lesson, you see in Liberia, people don't understand something and they just say yes, yes, yes. You can't do that with learning. If you don't understand the thing, we have to go over it until you understand it. That's the whole purpose of learning. It's not, I'm not preaching a sermon. You got it? A sermon, you listen to a few words in there and a few haps. I'm not preaching a sermon, I'm teaching. So I want the material to be that I want you guys to understand this thing. It will go over it and over it until you have to grasp the concept because this is life and death. This is important when it comes to system installation. It's very important. It's very, very important. Before you take a PV model to carry and put it on top of a roof, you consider the fact that they are wiring. And it's very important. So this is very, very, very important. PV wire and USE2 RHW2 are single conductor cable and have the same temperature, dry and wet provision as the THW2 PV wire and USE2 are sunlight resistant and are frequently used outside. Exposed to sunlight is free air, but only within the PV array, where the model provides protection and support for the conductor. PV wires is commonly installed as the conductor used between models supplied by the model manufacturer and between the area and the combiner of the combiner or junction box. So the PV wire comes, most PV models, sometimes they will come with a wire that you can use to join your PV models together. Yeah. And you can use them to connect it all the way to the conjunction box. But they're not wire you're going to use for home wiring, for your whole wiring. You need a wire to connect, and they are built for all of these. They can withstand higher temperature, they can withstand wet area, they can withstand the UV light from the sun. They are built to handle all of those things. Very important. Practically, you will see that as we go further. They say in the image on the slide below, the table we see PV wire or USE2 RHW2 going from the area to the junction or transition box. These are often installed underneath the PV array where they are terminated. Then THW2 conductor are run from the junction transition box in the conduit down to the next piece of equipment like the DC disconnect or the inverter. This practice of transitioning wire type is common on PV installation of all sizes. Let's see right here. All right, we'll come to that chart later. So that's a sweet part right there. They got a graphical illustration. conductor and application multi-conductor cables. So they're saying here, see the wire right here? Actually, they pair the wire out so you can see what in it. You have black, you have in the center, you see a little metal in the center, and then you have the white one. Not so? Who can tell me why there's the little metal in the center?
Neutral ground.
That's the ground. So that's the ground right there. There's a little copper in the center there. That's the neutral. That's the ground right there. That's very, very beautiful. Here is another type of cable that is common in all electrical installations. Multi-conductor cable consists of more than one conductor. Inside an additional outer jacket, two common examples are type NM, commonly called the Rocksmiths, and the TCER, the Trend Cable Exposure Run. The NM, known in the United States as the core Romix, the one manufacturer's name for it. It is commonly used for residential building wiring, running from breakers in a main service panel or the sub panel to branch sockets such as the plug, the outlet, the lightings, the range, the hot water tank, and basically any and all loads inside a room. Hello?
Yeah.
Isn't that beautiful? They just show you. Now, I think this is an appropriate wire for all your DC connections. Not so? I mean, for your AC runs. They're saying that this wiring is usually used for your socket breakers, for your break off to all the wiring done in the house. That's what it's used for in America. They are saying the NM, known in the United States as a core Romix. They have one manufacturer name of it. It's commonly used for residential building wiring, running from breakers in a main service panel or sub panel to branch sockets such as the plug outlet, lightings, the range, the hot water tank, and basically any or all load inside a home. It consists of two more insulated current, PVC insulated current, carrying conductor along with an air equipment grounding conductor, the EGC, all inside a nylon jacket. The NM is required to be in normally dry location, run inside walls, including space in concrete or block walls. A common type of NN is 12 and a half, meaning 212. The 12-2, meaning 212 AWG carrying conductor, one hot and one neutral. Just put a neutral plus a 12 AWG EGC, bare copper. An NM cable is shown on the left. See the cable right here? So if you are an electrician in Liberia, you can't tell me that you not come through, you have come across a cable like that, have you?
Yeah, cable
Okay. Now you do know that those cables are not capable to be exposed outside.
Yes. Not because they have a jacket or nylon on it, but it can be exposed outside.
Because it has a nylon jacket, so you cannot expose them outside. What's going to happen if they're exposed outside?
The UV will affect it.
The UV light, the sunlight will affect it. Now in Liberia, you see people use this cable to run from one house to another. Not so?
Yeah,
people use this cable, especially the people who do the generator thing, they're using the cable to run from one house to another. They say community light. What's going to happen with all the sun shining on this wire? What's going to happen?
It will break down jacket, the wire will be exposed.
Excellent. So when you're walking down the street and you see such a bad job, what do you think?
It was not on an experienced person that did it.
Okay. Now, I will give you an illustration of a man. There's a story of a man that went for a typing interview. He went for an interview for a typing to be a tapeze. He was downstairs and the secretary was upstairs typing. And while he was downstairs, the manager of the company was passing by, and he said it very loud. The person up there is making a lot of mistakes. The manager said, "You got a job." Why would the manager say you got a job? Because he knew his job so well that from the sound of the typewriter, he could tell that the person upstairs was making a mistake. That's how good you must learn things. That's how proficient you have to be if you want to stand up in society. That's how it is. That's how you do your job, knowing that I run this wire here. Maybe my child will walk under this wire one day. I run this wire maybe for some reason. Maybe you don't live in a community, but a relations of yours, somebody close to you, may walk in a community one day and that children play, the wire fall down and it's in Liberia, it raining, and that wire hit the water. What happened? You got people electrocuted. Lives are destroyed. So it is important. It is very important to say no. I can't do the job the way you want me to do it. It is important to say, hey, the person say, oh, but other electrician, they can't charge that much money you're charging. I call somebody in the middle, just say, my sister or my brother, I cannot do a job that will endanger the life of people. If that person is sincere, they will think about it, they will say, oh, that person know what they're talking about. So it's very, very important. Very important. This is a very important area when it comes to PV installation. Very important. Now we go to another common multi-conductor cable is a TCER, which is frequently supplied with macro inverter and used to connect them together in strings. Typically, the AC output of the macro inverter in TCER will be run to a transition box on the roof. Now, do you know what a macro inverter is? We have not discussed macro inverter. Does anybody know what a macro inverter is?
Macro inverter, small inverter.
So macro inverter means that every model on the every model has its own inverter. So from up the roof, the cable that comes down in a 220. I mean, come down in a DC, in a AC, so what it does, from up there, every panel has an individual inverter called the macro inverter that invert the current from DC on the roof, and the cable that comes into the building to the panel box or your junction box, it brings in AC current. So I can have 10 array of PV models, and each individual model has a macro inverter. Hold on, I want to show you guys a picture of a macro inverter. Hold on, okay? Let me see if I can find a picture of a macro inverter. We have one of the most common macro inverters, MPPT macro inverter.
Yeah.
Can you see my screen?
Yeah.
So this is what a macro inverter look like. This is what a macro inverter look like. So every model has this little macro inverter connected to it. Every PV model has this macro. A little bit expensive, but it's very beautiful. The good thing about it is, if you have macro inverters connected to your PV models, you will not have problem with soldering. You know what soldering is, eh?
Yeah.
So if a shell, if a shallow or something cover one of the models, you will not have problem with it, because you will still have the full output from individual models. Each model will be individually sending you a direct, AC current through the microinverter. It's a very beautiful thing to have. A little bit costing, but it's nice. I have a project that I'm dreaming of. I'm hoping to use microinverter. The project I want to use in Sport. I want to use microinverters. I'm planning on putting about maybe 50 panels, and then we sell current to the people. But I'm actually trying to see what's going on. I know that the government is now doing a lot of installation of lights in most of in the rural areas. But I want to know if they're just doing street light or they're doing home lights. So if they're doing home light, if they're just doing street light, then we can go in with this in the future. It's very beautiful. The microinverter, we will discuss it. It's a whole course on the microinverter. We'll discuss that and further. We'll go through that. So that's a microinverter. Let's go back to our lesson. So another common multi-conductor cable is a TCE which is frequently supplied with a microinverter and use microinverters and used to connect them together in strings. Typically, the AC output of the microinverters in TCE will be run to a transition box on the roof, where the conductor will be changed to THW2. So what they're saying here is you're still going to need your THW2 wiring from the conjunction box because you still need that wiring. So the microinverter not going to give you a cable that you're going to run directly into the house. No, but you're going to have a junction box that you're going to need your THW2 cabling. You're going to need those. Being changed to a THW2 in the conduit, and then continue on to the required disconnect and the point of interconnection for the PV system, similar to what is shown on the previous slide of transitioning wire type in a junction or transitioning box at the PV array. Shown on this slide on the right is a microinverter trunk cable, 10-3 TCR, which stands for 3 insulated current. That's what it said, 3 insulated current carrying conductor, plus an insulated EGC, individual microinverter plug into the trunk cable. The DG cable is a new designation of cable specifically designed for use in PV systems. It can be wet or dry rated and sunlight resistant. It is designed to replace the TCE arrow cable in systems that use a trunk cable, like microinverter system. Now here is a graph. Let's look at this graph right here. Let's look at the illustration right here. This is a beautiful graphical illustrations that shows how this works. Now these are our array. You have a PV array of what? 1, 2, 3, 4, 5, 6, 7, 8. You have a PV array of 8 array of 8 PV modules used for array wiring. Rated ampacity equal 40 amps. So number 10 PV wire. So you see the PV wire going over here. You see the wires going?
Yeah.
They're going to the box. Then we have number 6, the 10 THWN2 used in conduit. So right here, you see the use here. There's a wire, just a change. So you have your junction box here. You have a change in here. You got this coming over here to this is your battery banks. The charge controller, this is your battery banks. We have our inverter here. And then we have going into our socket box or the panel box. 20TH, you're going to better explain the diagram. This diagram shows a battery-based PV system to expound upon what types of conductors are used where. In general, the wiring types are similar with the main difference being the conductor type used for the battery, connection, and cables. All right, let's continue. The PV source socket are shown as 10 AWG PV wire. Where do we have a 10 AWG PV wire? Are you seeing them right here?
Yeah.
The 10 AWG PV wire. That's what it's saying here. The PV source socket as shown as 10 AWG PV wire with a rated ampacity of 40 amps. The source socket are run to individual fuse. You see the individual fuse? See the individual fuse in here? Each model in here, each runs here are sent to this box in their individual fuse. That's what I'm saying. Run to individual fuse. OCAPED. In the combiner box, where the single PV output socket is run through the OCPD and the charge controller to a battery bank. The PV output socket is run entirely in conduit, so it is protected from the sun, but still subject to moistures. For this socket, it is acceptable to use a THW2 wire, since it needs to accompany the entire combined current of full PV source socket. It also need to be charged than the individual source socket wire. Therefore, a 6 AWG conductor larger wire is required. So they're just talking about the different wiring in here. That's what this graph is spinning. You have a 6 wire here. You have the PV wire going into the conjunction box here. You have individual cells. So that's what they're explaining. But these things are easy to understand when we start doing them practically. You will see them physically, you will understand it. So that's what they're saying. This is a connection here. As you notice that these models are connected in series. You see them in series?
Yeah.
See them they are connected in series here. Negative, positive, negative, positive, negative, positive, negative, positive. How many series do we have there? We have 4 series, but how many panels in total?
8.
So 8. We have 8 panels, but they are connected in series.
So we can connect the panel to the series.
Yeah. So they are connected in series. You notice that this panel number 1, positive, is connected to the negative here. But this negative is a run going over here to the box. You seen it?
Yes.
Now, all negative runs that are going are not connected to a fuse, but all positive runs are connected to a fuse. You seen it? So you notice that the number one here, they are connected in series. The negative runs go up there. The positive run from number 2 goes into this conjunction box, but into a fuse. Number 2 here, the positive goes into the fuse. Negative go up here. That's what they're saying. So you do the connection in series. These are series connection, not parallel. These are series connection. That's what they're saying.
Okay. So when we connect it in series, then we're supposed to have a is it a controller that has a fuse?
This is a junction box. It has a time when you got a few slots.
Okay.
When you get a junction box, it has a few slots. You can use, you see the panel box right here?
Yeah.
The same way this AC panel works, it's a similar way this works as well. The same way. It's the same old way. But when you notice here, all the runs that are coming into here, there are only 2 runs from this junction box that are going in here. You have the positive runs from your fuse here going into your charge controller, and you have the negative run going into your charge controller. You notice that?
Yes.
So you have all these runs. You have 1, 2, 3, 4, 5, 6, 7, 8. You have this 8 runs running into your junction box, but you have only 2 runs from here, negative and positive run going into what? Into your charge controller. You got it?
Yeah.
Now from your charge controller, if you notice from your charge controller, we got positive going to the positive here on the battery banks, negative going to the negative here on the battery bank. The battery banks are connected in series. Right here, you seen it?
Yeah.
But the parallel, this is a parallel. This is all they're connected in series. And your parallel connection, negative to negative, that's a parallel. You got it?
Yeah.
So to connect all the battery in series, and the negative to negative is a parallel connection. So I combine everything together. Then I put one term out. That one term is the one that is I'm using to say this one term represents the entire connection of these 8 batteries. You got it?
Yeah.
I'm gonna go over it again. But we're not talking about this. Is now this is about wiring. We'll go over that when we get to battery bank connection and so forth. I don't want to. I don't want to confuse. The problem with you guys is that you guys want to learn everything too quick, and you will not learn like that. If you want to learn everything overnight, you want to learn how the battery bank works. You want to learn how. You will just confuse yourself.
Yeah, it's good.
It's like having a child who is learning how to talk. Then you want to teach them how to give speech. You got it? You got a baby, you're trying to teach a baby how to say a word, and you start telling the baby, tell the baby, instead of saying, say, apple, no, you tell the baby, say, I want to go to the bathroom. You think the baby going to learn that?
No, no.
Why not? Because the brain has to gradually absorb materials. So as we go along, these will make sense. I don't want to deviate from the topic. I'm talking about conduit and wiring today. I'm not talking about battery banks. I'm just trying to give you an illustration, okay?
Yeah, all
Let's
right.
not get off topic because that will confuse your brain. Then everybody now will start moving from thinking about the conduit and wiring, thinking about, no. Let's go slow, okay? All right, now if you look right here, we also have a run that is going into our inverter. We have 2 runs. We have a positive run and a negative run going into our inverter. Now, from the positive run and negative run going to the inverter, then we have what? 2 other runs from the positive run and negative run going where? Into your what? Your panel box. This is your AC box. This box is AC. You know that, eh?
Yeah,
So the inverter here invert your DC. All these are all DC connections. These are all DC. You cannot take the battery bank and put them after the inverter. You got it?
yeah.
Now, take into consideration, this is not a system that they are using an inverter charger. That's why they have a special charger for the battery. If this was an inverter charger, then this charger would be over here, which means it controls both DC and AC. But this is not an inverter charger system.
Yeah.
Now let's see here, let's continue. Since the battery bank can deliver a large amount of current to the inverter, the battery interconnections and lead leads to the inverter must be significantly larger. In this case, the 20 AWG is accepted. You see, they tell you the different type of wire they use along this connective. They tell you, yeah, they use 10, yes, they use 6, yeah, they use 2. You see the different type of wiring? From the PV model to your junction box, what kind of wire we use? Number 2, we use number 10 also. And these are PV wire. We use PV wire, the PV wire, the wire that comes, the PV wire that every PV model has a wire on it, but you can actually get a longer run. So we have a PV model that wiring that we use from our panel to our junction box. The reason why this is like this is because I think the junction box is up on the roof. Okay? The junction box might be up in this illustration. The junction box might be on the roof or go ahead.
The junction box is in the roof. They did a connection to that bring 2 lines down.
Okay. Great. So what I want us to grasp from here is that the fact that can you see the convection of wires?
Yeah.
Are you seeing the transition of wirings?
Yeah.
Number 10 PV wire, that's what we use all the way to our junction box. On our junction box, over here, over to the charge controller, we use what? Number 6 THN or / the THW2. That's what we use over here. You got it?
Yeah.
We use that all the way to our battery bank. Now, from our battery bank to our inverter, we wire change. Our wire change to what? 2/0 THW. So there is a change of wiring in the in the system. You notice that 10, 6, 2. So this is a PV wiring, PV wire. This is a THW2 wire right here. This here the THW. So we have different wiring in that connection. That's why I want you guys to understand. All right, let me go down. Now they say not shown on the slide, the AC output of the inverter to the electrical panel is most likely the TAW2 in conduit. So they are saying here, even though they didn't show what wiring is here, but they say most likely this wire that leads from here to this here will be what? THW2, and it is in the conduit. Also,
Yeah.
it is in the conduit. When you do proper wiring and your wiring is in the conduit and they look professional, when people come in and look at your work, they grade your work with respect. That's all.
Yeah, that's true.
They look at your work, they say, yes, this guy know what he's doing, especially professional or educated people. They know, they know. They know what you're doing. Like, I remember when I went to the LOIC, that was 1996. Yeah, 1996. I attended the LOIC and I did residential plumbing. And I was a very young man. I think maybe 15 or 16 or something around there. I went to that school. I had gone there to do shoes making like every other young kid my age around because you had to be, I think, 18 or something to be there. I was less than the age, but I, I got in somehow. After the entrance or something, I got in. They accepted me. But I was very small. I was the smallest in the whole school, I remember. I was very small. So apparently I used to be like the child to almost all the people in the school. They used to pick on me all the time. So there was a lady there who she's in America now. She and her husband. The the husband was a representative in Liberia, Mr. Dupe. And I went to do shoes making, like every other kid would do. But then at the orientation, they were talking about plumbing. And I talked to the fact that it has some decency, it has some uniqueness. So I went the next day and I said, I want to change my major to plumbing. And I enrolled in the plumbing class, plumbing area. And in plumbing, when you done installation of your plumbing appliances and your wiring and you done everything, your tile laying, if you are a plumber and you just walk out of there without cleaning the place, without polishing and shining the tile, what's gonna happen? The person who you're working for will not see the beauty of your work. Is that right?
Yes.
So you are taught that you are also a cleaner. You also have to make sure that you do a job at the end. You clean everything. If you have to wash the car, make sure it's shine. When the person walk in the bathroom for the first time, they feel good. That's the same thing with wiring. It is important you can do a nice solar installation on the roof. The person not saying that with solar installation on the roof, but where you're gonna install your inverter and your battery and everything, you can't do all kind of wire, one wire running on this side, the other running on this side, and some when the person come in and look at the work, even if they know nothing about what you're doing, the fact of the matter, their eyes can see on uniqueness, they degrade your work. You got it?
Yeah.
So it is very, very important to take these into consideration. All right, let me look at the, yeah, that's what I'm saying here. Now let's say over here, conduit field. Much allow for heat dispensation, installation, or removal. Allowable enormous of conductor in a conduit. Depends on the conduit type and size, the conductor size, the installation type. That's what it's showing here. A number 10 AWG2 have full conductor in it.
Yes.
You seen it?
Yeah.
Then number 5 here, we have what? 5 in it. So this is half schedule 80% PVC conduit. So they're saying all around here is 80%. The conduit around here, so what 80% of it is the protection. Also, 80% of this whole wiring here is the protection of this full conductor in here. 80% is all protection. Here, 40% is all what? It's all the protection. Insulation. Let me use the right word. Insulation. It's all the insulation. That's what they're saying. Now that you have learned a bit about the different conductor and conduit type, let's combine the two and talk about conduit field. Annex C in the NEC specifies the maximum number, type, and size of a conductor that can fit in each size. In each size, can fit in each size and type of the conduit. If all the wiring are not the same gauge, longhand calculation may be required. As this slide shows, 410 AWG THWN2 conductor can fit in half schedule 8 PVC conduit. Now, you know the conduit. You know the conduit is to protect the wire, and also.
Yeah.
Now, what they're saying is, if I have this right here and I decide to put 10 wire in this here, is that right? In this conduit, I decide to put 5 conductor in this conduit, is that right?
No.
So what they're saying is there are a required amount of conductor you can put into a conduit. That's what they say. When you are filling the conduit, there are required amount of wires that goes into a conduit. Because the conduit, if you look at the conductor in here, they are separated. They have space in there. Why is that? They don't want them to be hitting one another. Not so. They don't want them to be hitting one another. That's why they make sure to tell you how much of a conductor you can put into a conduit. So they're telling you how to fill in the conduit right here. And that's an NEC requirement. Now let's look right here. Conductor fills. A conduit fill. For a given conduit size, outside diameter are the same. Schedule 80 PVC conduit has a thicker wall than the Schedule 40. Metal and flexible conduit all have different wall thicknesses. To determine conduit fill, number of wires allowed, refer to NEC cable or calculator. We'll look that later on the NEC cable or calculator. So they are telling you how much, you see this conduit here? They tell you how much you can put in there. Conduits are referred to in normal or trade size, meaning they are rounded to half, quarter, once, or 2 inches either. They are also referred to in metrics designators, which are only identified numbers and not actual diameters or dimensions. Depending on the type of conduit, the inner and outer diameters are likely to be slightly different from those sizes. Some conduits have thicker walls than others, and this must be accounted for when calculating the conduit fill. Hello?
Yeah.
So if you are an electrician, are you taking this into consideration?
Taking into consideration
The conduit calculation, depending on your runs, you have to know how much of a conduit you need. How much of a conduit, how many conductor you can put into a conduit. So if you underestimate the amount of conduit you need, what's going to happen? You're going to start forcing the conductor into the conduit, which is against the code.
Yes.
Not so?
Yes. What would happen?
Go ahead.
I said that exactly what will happen.
Okay. All right. Now the NEC has tables which provide allowable quantities, wires in different conduit types. Based on conduit size, wire AMG, and insulation type, these tables assume that all wires in the conduit are the same size. The other option for calculating conduit fill is to manually calculate the area occupied by conductors. Now, if my daughter said to me, I'd like to be a nurse. I said, you can't be a nurse. Why not? It's my child. I'm supposed to motivate her. I supposed to tell her, oh yes, you can be a nurse. She don't have what it takes to be a nurse. She doesn't like to read. She don't like to study. What's going to happen is she go to nursing school and pass school some kind of way and become a nurse. She go, now, tomorrow, she'll get somebody the wrong medication, the wrong treatment.
Yeah.
But you can be something else, my child. You can work with something that don't have to hurt somebody. Am I a bad parent? No.
Yeah.
Am I a bad parent? I just tell the child, this is your capability. This is what you're good at. This is what I know you can do. You don't like too much reading. You don't got patience. But you have human personal skills. You're good with people, so you can make a good sociologist. You can work in a human service, yes. You can be a counselor. You can tell somebody why not to hurt themselves. That you can do. You got a gift. But you cannot be somebody to administer drugs to somebody. Somebody will say to me, why you say that? The reason is because I'm the father, I have determined the ability of that child. Am I going to force the child to be what the child don't have the ability to be? So that's exactly, I just give you that illustration in the sense that if you're an electrician, remember you are a life, you provide light, which is becoming which I can say is a necessity to the well-being of every society. It's a necessity. It's necessary that we have light. You can live without light. It's not a fact need. You can live without light. Librarian will know about living without light. But it is a necessity, something that is necessary to have, because it enables a lot of improvement. With electricity, you will be able to study at night if you are a student. With electricity, there will be a less crime rate. People would the place is bright. People don't do bad things in the bright. They do bad things in the dark. So it is very important to understand that what I'm trying to build here is a team of installators, a team of technicians that will stand out. If I were to send members of my team to work with another team, I want in the future my team to say, we can't do that job. I want my people who work with me to say, we cannot do that job, because the needed equipment or material needed to do that job amicably, that job will not be detrimental to the well-being of people or human beings, is not provided. If you can say that, then you are a proficient. That means you're a professional in what you do. It's easy to be an amateur, but to be a professional, it means that you have to stand up for the right things to be done. So what I'm saying here is they already gave you a guidelines of how many conductor can go into a conduit. Some conduit will only take 4 conductor. You start putting 6, 7 running. You know, sometimes you see the electrician, they're forcing the wire in there. They're forcing the wire in there. It's not supposed to be that way.
There is something that I saw already.
Huh?
I said there is something that I've already seen that it will tell us to do. If we have half inch square and we have 3/4, we have 1 or 2 inches. So when you know that it can't fit inside the 1 inch, you go about 2 inches.
Excellent. You know for you do the right thing. Good. The National Electrical Code, the NEC wire coding, color coding. I think some of you guys know about color coding. What wire color coding?
Yeah.
Now, the NEC tip, they say the equipment ground. DC, AC, no differentiation between the AC and the DC. The NNC coding is green, yellow, or bear. The grounded, typically neither may be negative, neutral, white, or gray. Underground, typically both may be positive, hot, L1, L2, L3. They're anything but green. You use any other color but green. Green, yellow, bare, white or gray, typically black, red, blue. Color coding of wires slash conductors is a way that electrician can speak to each other. You got it?
Yeah.
Color coding of wires and conductor is a way that electrician can speak to others. Table shows the correct color coding of wire based on the NEC for USA. When I used to teach computer in Liberia, I had opportunity to teach at a program in Liberia called, in Monrovia. It was called a Liberia Network Technology. And then they had a project with the disarmament program in Liberia. You know the disarmament program?
Yeah.
So they had a lot of these children, a lot of young people coming in, some of whom were affected by the war greatly, some of who had to participate in the war and so forth. But the owner of that institution was angry with me because my classes was longer. I think he wanted me to just run through it, and I would just teach halfly. So I think he wanted me to teach, I think 3 or 4 classes at a time, but apparently he was having problem with the fact that I was making my students to shut down the computer and put the computer themselves instead of just coming on the computer and start working. And there was an incident where a girl who everybody knew that was a good student, who was going to be a proud employer of an institution that was going to give the school a great name, were called for an interview. And the institution was very confident that the girl was going to nail that interview. I think it was a United Nations job or something. She was going to nail that interview. They told her to boot the computer. This girl knew how to work perfectly in Microsoft Word. She knew perfectly how to work in Excel's Access. She could type well. But every time she came to school, the computer was already on. So she was never taught how to put the computer on. So she couldn't put the computer on. She didn't know how to press the button, what button to press for the computer to come on. And she failed that interview. It's not a negligence of the students. It's a negligence of the teacher who failed to teach the student the requirements so that when she are faced with such interview or opportunities, she can be prepared. I don't have money to give you guys. It's not a bigger institution. But I can tell you, I don't have a PhD, a master, or whatever portfolios. But I'm gifted. God gave me a gift to be able to learn things and be able to teach them. If you are humble and willing to learn, together we can learn together. And together you can stand up. I have boys in Habel today. Some of them work with Firestone. They've been working for years. They never lose their job. On the day they go higher, they've been working there. I think some of them are junior staff now. These were boys with me in my computer program I used to have there. I used to tell them to practice. Practice. Never had a job. Practice. When the opportunity came, they were adequately prepared. They were ready. I think my mother used to say, or somebody said to me, you are a hunter. Always load your barrels. Barrel is like a gun. Always make sure your gun is already fully loaded before entering the bush. Because if you see an animal, you will bring home a meat. But if you left your ammunition home and say, let me go look in the bush first let me go check to see if there is an animal in that bush. See a deer running in front of you, now you got to run back to your house to go get a barrel. What happens? You're not prepared. So you have to prepare yourselves, guys. I put a lot into these things. I put a lot. I put a lot. I put a lot of sacrifice. I put a lot. Trust me. I can tell you. I put a lot of time, a lot of tiredness. I put it into this because I want the best for the few I can train. You don't have to work with me in the future, but I will be proud. Some of you tomorrow, maybe I'm home, I'm old man walking down the street, and say, hey, Ben Sati, you know me? One time in Habel, there was this thing here where they were, I think, arresting people. They had a vigilante in Habel. We couldn't be out at a certain time or something, and I was coming from the airport at midnight. I went to work and no money, so I had to walk. I used to walk from RIA to Habel almost every day. Midnight, the last flight leave around 10. I'm walking, so I was walking. I walked all the way to Habel, no car anyway. I was walking, and the guys were running after me because they thought I was one of those criminals. And somebody noticed me. The guy said, "Oh no, guys, that's the professor, the guy who teach computer to the computer school." Now I didn't know that young man. I didn't know him at all. I could be mobbed for no reason. I could be beaten for no reason. But whatever you do it to the fullest. Even if it's not profiting you, because tomorrow people watch, people are looking, people see. You do a job, you do the right job. Somebody sees the coding of your job, your wiring are in place, the this is in place, and that is in place. You know, some of my good friends in Habel, I was friends with people like Ligori Sega Chibo, where I used to admire greatly, great man. Rufus Kamo. I used to go and speak to those guys. Those were people who were I could look out to and say, I could be like this guy. But they were humble. If you have the ability to sit down and learn and read, don't get pride. Don't say that you are exclusive. If you develop exclusiveness and proudness, you are in for failure. Because even Bible says, he who humble himself shall be exalted, and he who exalts himself shall be humble. If you are smart, I had a lot of brilliant friends going to school. Some of them didn't go far in life because they were already proud and bigotry from school. I'm not saying that's the reason, but I'm saying it's good to be humble. What I'm saying is that we as a team, this team here, we are trying to build. I want this team to be a good team. I want us to be a good team, a real good team. I want us to be a team that when people refer to us that we, in the future, you and I, we are just John the Baptist. Let me just say to you guys, we are just the John the Baptist of this establishment. We are clearing the way for the young generation that Alberto them will enjoy what we're trying to build. We are just the John the Baptist. We're trying to build a way that young people can have an opportunity. I live in a developed world. One of the good things I notice about Westerners, the Western man will write down his experience and ideas so that someone can take that book and read that ideas and experience and practicalize it and put it to work and improve on it. The black man don't do that. The black man stand with bigotry and proudness and say, I am the master. I'm the one-eyed man in the town. The white man don't do that. The reason why the Westerners excel is because they are open up with information. They are willing to share information. You go to a new job and there's a white person standing next to you. You ask him questions. You have no problem showing you how to do the job. Have a black man standing next to you and ask him to look at you and say, I'm not the one that's supposed to teach you. Because that is the mindset we have. I live in America. I see African people go to work. They're fighting one another at job. Very fighting one another at job. They're at job. So I'm going to say to you guys, we can do great. We can do marvelous if we put our mind to it. I want you guys are in Liberia. You got all the time. all the beautiful places. If I'm in Liberia, there are a lot of, I can go and sit down. I can go and sit down in a rubber farm and read my book. I can go and sit down close to the water and read my book. I can go down to Marshall if I want to sit down next to the ocean. That everything to be in a beautiful environment, something that some of us don't have. We have the beautiful, and I live in a story building on the 7th floor. I don't have a Porsche. My son can play. He run around in the small place here. It costs almost $1,500 a month. Imagine me living in Liberia and my child have a yard to run around. It cost me $1 million to provide him that luxury that you have. It cost me $1 million. I will have to be in the million. I have to have hundreds of thousands to provide my child the opportunity to have a yard to play. Something you have. It's all around. So spend time with material. Read. Practice. Because when you are professional in what you know, when the opportunity comes, you'll be good. You will be good. When the opportunity comes, you will stand up. Somebody will say, I know a guy living in Can 1, way behind Can 1, in one sing hall. But boy, that guy knows his job. It's very important. Not everybody is quick to learn. Some of us not. Some of us will read one thing, 1 time, 2 times, 3 times. But familiarize yourself with the practice. I'm thinking about sending some material just for practice, that we have a place where we can just go and do installations and just practice. If you're on the group page, you notice that yesterday I sat down and I designed a motorbike with a little thing behind it that you can put a solar panel on the top and put a hospital bed there, that somebody in the village, where in the village can be transported. If they have to be transported to a bigger town, if they die, they can have a little motorbike that had a bed they can lay it on, connected to a motorbike. I sat down and I designed it. That's an idea came to me. I sat down, so I saw it somewhere, and I said I can improve on this. If you have the ability to think. I never wasted my time sitting and arguing. Like when people like to argue, I don't waste my time with that. Put your mind to work. That's your gift. That's your weapon you have. Put it to work. That's the mind. You have some of the if you live in development, you have some of the in developed countries, women like brilliant men. Brilliant. If you're brilliant, women like you because you may be 4 feet tall. But if you are smart and brilliant and you're a man that can make change, you have good women. Practice. Practice. When I was a boy, my father used to spank me a lot, and I hated it. But when I grew older, I realized that you have to practice. Some of us, we came from poor family. Poor family. Never had a birthday party either. Some of us came from a poor family, but your life doesn't define you. That just gave you the opportunity to have the tenacity to want to do better. That's what it gave you. Say, I can do it. I can be part of the change. I can be part of the new Liberia. I can be part of it. And you don't know where the wind will blow you, bro. You don't know. This is life. Tomorrow you can be here. Tomorrow you can be somewhere else in the world. You don't know. So whatever you do it to your fullest. Whatever you do it. Convince yourself. I was saying to my daughter the other day, I see that she's scared. She's getting paranoid because they're going to have an exam. And I said to her, the only reason why you are afraid is because you didn't study. I said, when you studied, you don't have to be afraid. The time you take to be playing around with your friends, if you were taking that time to read your book, even 1 page every day, you will be okay. But if you wait for the time for exam before you open your book to study, you're not going to be okay. You're not going to be okay. So this is not an academic school, you're adult. I'm not going to say, okay, every day I'm going to give you guys quiz or test. But when I ask questions on materials that I sent to you guys, I want to make sure you guys are responsive. Because that alone motivates me, made me feel better, it made me feel that we are going somewhere, we are doing something. I understand everybody got other things they're doing, but if you want to do this, then you got to be committed to it, because I am committed. I am committed. I could spend this time right now making money. This time right now saying I could spend this time somewhere doing something else. but I'm committed. I'm committed to this because I believe in it. This is what I asked God for. This was my gift. I didn't ask God bring me to America and give me a big house and make me rich. I never prayed that prayer before. When I was a boy, my mother used to say to me, when you pray to God, say, God bless me that I may have, but not too much that I will forget you. That was the prayer. I may have, but not too much that I may forget you. So that's a chart of the color coding right there. The international coding, color coding is in your material. You have the chart to tell you the chart. It's right there. This is one of the most beautiful programs you have. You have materials that cost hundreds, if not thousands of dollars. Make use of it. Make use of it. All right, guys, that's the end of this class.
Thank you. Thank you, thank you very much.
I think I want to give you guys time to I don't want to do another topic. I want you all to go over this topic this week. Go over it. You're gonna get a material figure. Please print a material for the students. Do your part. Do your job. Do your job the way you should. Make sure the student have the material. That's your responsibility. You have agreed to do it. So do it with all due diligence. Because you know me. My mouth is not behind my head. It's right here. If not, anybody in there know me. You know me very well. So I want you to make sure that the students have the material so they can read before their class, so they can have it. I don't know if everybody, if you can access on your phone, because I know internet being in library is hard. If you can download it and have it, even if you download it, everybody can, because it's a PDF. If you download the PDF, anybody can upload it on the phone. It's easier if you have something on your phone, because how many times you look at your phone a day? The average person, I guess, look at the phone over 2,000 times a day. If I may say, because every 2 seconds, every 2 seconds, every 2 seconds. So if you have it on your phone, maybe you can spend at least 20, 30 minutes going over it. But you have to familiarize yourself with the material and be on course. I really do want you guys to be able to grasp the concept, understand what we do. And I sometimes, when I record the training, I send the recording also. The training record, like the class we did today. I record all of these classes. So there's a repeat video that goes on if you followed our WhatsApp page, every time I upload these materials, the links are there. Every time I upload them, the links are there. You have to give in. The 2 seconds you will take to go on your internet to check it out to see if there is a new material over there, or you check your email, do that. If you met a girl and she tell you, say, I'll call you, and you really want that you look at your phone almost 5 different times a day, waiting for that one call.
Basically, when you tell them, giving an appointment or a appointment, you look at
you see the professional tell you guys. All right, guys, you gotta have a good week, good weekend. The material for next week. Now, the thing about the week in a week, I know that some of you guys go to school or got other engagement. So when I do the material and I send it, you can read through it. I think maybe if there be the need, in the week I will find a time to do the other material and send the video the same way I did, so you can watch the video. Those of you who will not be in the Friday class, you can watch the video to be part of the training as well. Also, I think we have an installation to do at our center. So there is at our center the inverter and the other stuff is going to be delivered tomorrow. We have a little small installation to do at our training center in Habel in Cotton Tree. And I think you guys will have to do that job.
Yeah,
yeah. The panels are already there. The panels are already there, and that is for our program. And I would love for the fact that you guys can do that job. It's a small job. I show you guys can do that little job. That go over there, meet Mrs. Robertson, and we can do the installation and run the wires so that those girls can have lights in the center, because apparently the girls want to stay longer in the evening to do their tailoring training. You know that the Voma and the Job Corps program, they are intertwined. The Voma and the Job Corps programs are intertwined. So even in the future, if we decide to incorporate other vocational programs in that area, we may be taking staffers from Voma Energy or Voma Corporation that will be facilitator of that entity as well. So I don't know how many of you have been to the center in Cotton Creek or seen the center.
I saw it. I've not been there before.
Have I been there before?
Yeah.
Yeah, it's in Cotton Tree. We're going to actually extend the front to do a showroom and add more machines so that they can start sewing clothes and stuff and selling clothes. What happened to the girl sleeping on the computer? She's not well?
But I want to explain how I need to teach about I want to come and
Oh, you're supposed to teach her, but she can't practice while she's sleeping.
know that machine will sleep on like in 3 months. I thought of it. I got to put a new course. I thought of it.
You didn't put the computer on you didn't teach her how to put the computer on?
She know. Yeah.
Because the other girl over there, I see the other girl over there doing her training.
What?
The other lady over there she's doing her typing.
On Microsoft.
Yeah, I see. How many students you have in that program now?
Basically, I have 5 students.
So you have 5 students in that program?
No.
Okay, so that's good. That's good. We have to work on that. We have to work. I think I'm trying to get more computers. I'm trying to get more computers. I wanted to make it not just a computer program, but I wanted to do something a little bit about little secretarial. A little secretarial, not just so they can learn a little bit of secretarial science, not just computer, but a little bit of secretarial science, so that you can make it a potential career. Not just knowing how to work on the computer, but a little bit of secretarial science as a course. Um, we work on that as well. So we work at that in the vineyard. We do. And those of you who knows about computer can also volunteer if you want to volunteer with the program. As well. So well, guys, let me leave you guys. I want to go and spend some time with my family. It was nice. I think I may be able to upload a review of this training program. You guys have a great day now.
All right.